We recommend that you accustom yourself to the more reliable tapping technique. Once you're capable of generating an arc with ease, your next task is to practice maintaining the arc at the proper length and transferring it sideways. When an arc is generated, the core wire of the welding rod melts and the coating flux decomposes and gasifies, steadily reducing the length of the rod. Therefore, if the holder continues to be held at a constant height, the arc will become longer and eventually vanish. It's necessary to learn how to supply the welding rod while maintaining a constant arc length. You do this by lowering your hand at the same speed with which the welding rod is being consumed. Generally speaking, the arc should be about the same length as the width of the core wire's diameter. In our example, the core wire is 4 mm in diameter, so the appropriate arc length is 4 mm. However, you should be aware that the protective tube blocks some of the arc from view. This being the case, if the visible part of the arc length is about 2 mm, consider it appropriate. A bright cracking sound can be heard when the arc is maintained at the appropriate length. However, the sound becomes duller as the arc gets longer. Learn to listen to the arc and adjust your arm accordingly. Once you've mastered the skill of maintaining a constant arc length, your next challenge is to learn to transfer the welding rod at a uniform speed and in a straight line without changing the arc length. Begin by tilting the welding rod 70 to 80 degrees towards the direction of movement. A raised belt of black material, known as slag, forms on the track of the welding rod, protecting the deposited metal. Deposited metal is a solidified mass of molten core wire mixed with molten base metal. The slag is broken by the slag hammer and removed, revealing a metallic section whose glossy silver surface has a wave-like striped pattern. This is known as a bead. Shifting a welding rod in a straight line creates what's known as a stringer bead. Here's a tip you should heed when depositing a stringer bead. The speed of welding rod transfer, the arc length, and the welding rod's tilt angle should be adequate and uniform. Recommended width of the stringer bead is 2.5 times the core wire diameter of the welding rod used. This means that the stringer bead width should be about 10 mm for a rod with a core wire diameter of 4 mm. When welding is started, a liquid substance known as a pool appears under the arc being generated. Watch the pool carefully as it grows. Once the diameter of the pool is almost equal to the width of your desired bead, begin to shift the welding rod sideways. Once you can perform this operation naturally and without difficulty, you will be able to create and deposit a neat stringer bead. In other words, careful observation of the pool is the first and most vital step towards welding proficiency. The bead is most vulnerable to defects immediately after you begin to generate the arc, because the arc is still unstable and there is not yet enough shield gas. Also at this point, the base metal is still cold, a condition that often leads to weld defects such as incomplete joint penetration and incomplete fusion. Meanwhile, a cavity known as a crater is created if the arc is suddenly discontinued at the end point of the weld seam. Insufficient bead thickness and sudden cooling mean that craters are highly prone to cracking. Therefore, you must use the retract start technique at the bead start point to stabilize the arc. At the end of the bead, discontinue arcing after filling any craters by moving the welding rod as if you were drawing a circle. When a welding rod runs out halfway through the weld, you must stop welding and resume welding after replacing it with a new rod. The procedure for joining beads is as follows. Shorten the arc length and immediately discontinue welding. Remove slag around the crater and clean the area. Start an arc from a point slightly ahead of the crater. Return the rod while providing preheat using a slightly longer arc. Continue practicing until the seam joint does not stand out. When you're performing V-groove butt welding of a medium or thick plate, it's difficult for a stringer bead to cover the weld seam width of the upper layer. In this case, we solve the problem by using what's known as weaving bead operation, a method whereby the welding rod weaves between both sides of the weld seam. The resulting bead of greater width is known as a weaving bead.